Okay, these are the notes for section 2.2 in unit 4 of Algebra 3. We're continuing our study of functions and the important aspects of functions. We're going to talk about increasing, decreasing functions, and it makes a difference if a function is rising over time or falling over time, and so we want to analyze that information. So if I look at this graph right here, I can notice that we're going to say that this graph is starting somewhere way over here. We don't know where it starts. We're going to assume it starts at negative infinity, and it's constant. It doesn't change going up or going down at all. So from that interval to this interval, this is constant. So this is constant. From negative infinity to negative 2. It's not, I don't use brackets at all with intervals because at negative 2, it's not saying it's constant at negative 2. It doesn't change at negative 2 at all. It's saying that it starts at negative infinity, goes to negative 2, and at negative 2 something changes about it. So we're not going to use a bracket, we're only going to use parentheses. Then this function starts to decrease. If you think of it as a negative slope, it's going down. It starts going down from negative 2. Oh, I'm sorry, it wasn't a negative 2, it's a positive 2. Let's go back and fix that. I'm not reading my graph correctly. So it goes from negative infinity to a positive 2, constant. And then it goes from decreasing, starts at 2, it goes to 4. Notice I don't care about the y values. So it's decreasing from 2 to 4. Once again, they're parentheses, not brackets. Then at 4, this function starts to turn and goes upward. This part where it's going upward is increasing. It's got a positive slope. So that means it's going to go from 4 and it stays increasing until it gets to 8. So this is increasing on the interval from 4 to 8. I don't care about the y values. I just want to know the x values, the domain. And then from 8 on, and we're going to say it goes to infinity, is this constant again. So from 8 to infinity. That was a fairly easy graph to read everything off of. Sometimes you're given a function. So here's a function, x cubed minus 3x plus 2. And being able to find the intervals with a calculator is important. So the first thing I'm going to do is I'm going to make my calculator look like this one. So I'm going to go to the y equals, let's turn it on this side, see if it's less glare. Okay, and I've got x cubed minus 3x. And I want the window to look like that one. Notice it does not look exactly the same. So if you look at this window, it goes from negative 3 to 3. So I'm going to change my x min to negative 3, my x max to 3. And each hash mark is actually a lot less than 1, but I'm going to leave it like that. And then it goes from probably about negative 7 on the y to about 10 on the x. Now it should look fairly similar. Okay, it does. It's good. So that means I want to know this is increasing here. From here to here, it's increasing. It looks like it's increasing until it gets to 1. So if it goes increasing, this is increasing along here until it gets to this point here. But I can find with my calculator exactly where that occurs. I'm going to find, this is called a maximum point. That's where it's changing from increasing function to a decreasing function. So I'm going to do second and trace. And the maximum is number 4. And I'm going to do my cursor, move my cursor left of where that is a maximum. As anywhere left is fine. I'm going to hit enter. And I'm going to go to the right of that. And wherever I'm to the right of it, I'm going to hit enter. And when it says guess, I'm going to hit enter. Okay, so it says negative 1, 4. So I was right. So it's increasing from negative infinity to negative 1. Then the function changed and went from increasing to decreasing in this area. So it looks like negative 1 to 1, But I'll check in my calculator. So I'm saying it's going decreasing. Second trace. So here where this occurs is a minimum. So I'm going to go to number 3. I'm going to go left of that point, and then I'm going to go right of that point. Hit enter, and when it says guess, I hit enter. It says 0.9999811. Well, that really is just 1. Your calculator is approximating it. So this point right here, it started decreasing a -1 and was decreasing until it got to a +1. And then it changed again. Now it's increasing again. And this is going to keep going forever. So I know that it's increasing from 1 to infinity. And once again, it's very important. You do not ever want to use brackets with this. It's always parentheses. And then relative maximum and minimum. If you have more than 1, it's a maxima, and more than 1 minimum is a minima. So it's when a function changes from increasing to decreasing. That's exactly what I did here. It was changing from increasing to decreasing. This is a relative maximum. I'm going to do just a bunch of squiggles. This would be a relative max. This would be a relative max. Because it's increasing, then it changes to decreasing. Increasing, change to decreasing. And when a function changes from decreasing to increasing, so here's the decreasing, it's going to increasing. Right here is a relative min. Right here is a relative min. It's a concept we study more in depth in calculus, so that's why you're introduced to it here. The other thing about graphs that are maybe useful is this idea of symmetry, and I'm not going to do a lot with it this semester, but there's something called even functions and odd functions, and they're helpful in upper level mathematics if you understand the characteristics of them. So an even function has a y-axis symmetry. So a good example of that, if I were to draw an xy axis, and I drew a quadratic that looked like this, that has y-axis symmetry. And why it's useful is whatever I say is from 0 over is the same from 0 to the left. So that's why it's important. Odd functions have origin symmetry. So a classic one is an x cubed. Notice I've got everything in the first quadrant here is the same reflection in the third quadrant here. This has got origin symmetry. So if I know something about what's happening in this first quadrant, I can figure out what's going on in this third quadrant. Likewise, the second and fourth would match up. If something has symmetry over the x-axis, let's give you an example. So here's part of a graph. If I reflect it over the x-axis, it looks like that. So this is not a function. So we don't study it in this course. Piecewise functions are probably one of the more difficult ones for students to get a grasp on. I'm going to show you how to evaluate them numerically and then how to do it graphically. So a piecewise function has pieces. So this is the domain. This first graph, 2x plus 1, is for x less than 3. So if I think of it this way, I want numbers that are less than 3. So I could say 3, 2, 1, 0, negative 1. I can keep going. So this would be my x. My y would be 2x plus 1. If I put a 3 in here, 2 times 3 is 6. 6 plus 1 is 7. Okay, but that's points not included. So when I graph it, I'm going to plot the point 3, 7. But I'm going to make it an open circle. And I put a point 2 in here. 2 times 2 is 4. 4 plus 1 is 5. So I could plot the point 2, 5. I could do the same thing with 1, 2 times 1 is 2. 2 plus 1 is 3. 0. And then negative 1. So 1, 3, 0, 1. Negative 1, negative 1. So, 1, 3. I missed the point. Not very straight, but that's what that looks like. So this is saying for everything that is left of 3. You don't want to go right of 3 at all. You're just going to graph anything that's left of 3. So if I wanted to evaluate this function, if I picked a number that was less than 3, I would choose one of these numbers. But remembering, not included here. Now let's look at the next function. I want x greater than or equal to 3. So I can do this again. I have x here, but I want numbers greater than or equal to 3. So 3, 4, 5, 6, 7. Now I'm going to use this negative x plus 4. So if I put a 3 in here for x, negative 3 plus 4 is 1. So if I plot the point 3, 1, now it's including that, because this is saying it's equal to. If I put a 4 in here, negative 4 plus 4 is 0. So I plot the point 4, 0. 5, negative 5 plus 4 is negative 1. Negative 6 plus 4 is negative 2. Negative 7 plus 4 is negative 3. And I don't need to plot all those. So this is what it looks like. So my domain is x is less than 3 for this part. X is greater than or equal to 3 for this part. But the domain over the whole function is going to be all real numbers from negative infinity to infinity. Piecewise functions are, they're harder for some students to understand, and I think that's why we go over them so many times. You might have seen them in Algebra 2 if you had time to do them. We do them in Algebra 3, and then they're a big part of math analysis and calculus. The other function that we talk about are step functions. They're also named greatest integer functions. The graph forms steps. So it has to be a function. It has to pass vertical line test. And it's usually written as f of x equals the greatest integer of x, like this. And different books write it different ways. I believe this is how your books do it. And I think of it as a number line. So these are all my integers. And I could keep going further out. So if I wanted to take a table of values and took f of x is greatest integer of x, and I put all these integers here. Well, it's easy. If I put an integer in here, I'm going to get an integer out. Where it becomes interesting is when I pick a number that's not an integer. So if I pick negative 1.5, so negative 1.5 is right here. Negative 1.5 goes here. The greatest integer that's included in negative 1.5 is always going to be the integer to the left, so negative 2. So now if I start graphing that, what it looks like, I could put the integers in that I had. Negative 1.5, negative 2. So no matter what fraction I put in that's between negative 1 and negative 2, I'm always going to get negative 2 as an answer. So when it gets to here, this will be an open circle. Likewise, if I chose 1/2, if I put a 1/2 here for x and I took the greatest integer of 1/2, I always have to go to the left. So here's 1/2. If I go to the left, it's 0. So everything between and that's what it looks like. It looks like steps. Your calculator does it. So I go to math, over to number, and it's number 5. And it says int, and I just put an x in. And I look at the graph, and you can see the steps. I can even make this a little bit better of a window. Let's do negative 3 to 3. With the calculator, it does not show you the open and closed circles, so you have to understand which are open and which are closed. Step functions are modeled in a lot of situations. Step functions can be used in modeling how many pairs of jeans somebody has bought. So if you're buying a pair of jeans, you would buy an integer amount of jeans. You would buy 5 pairs of jeans or 6 pairs of jeans. You cannot buy 5.6 pairs of jeans. So it's a discrete number. It's not a continuous function. And that's what this is leading up to, is getting you to understand continuous versus discrete. Step functions are also a function that are done later on. Those are the two things I think people will struggle with the most, this idea of the piecewise functions and the step functions. So if you need help, just let me know.